Hello everyone, welcome to the image processing series in MATLAB or SCILAB. Here we will see the image matrix operations such as zeros, ones, arithmetic and the visualization. So in this video we will learn how to use the binary image matrices, that is ones and zeros, in MATLAB or SCILAB. Here I'll be showing the practical thing or the practicals in the SCILAB because it is an open source software. You can do the same thing in the MATLAB also. Then next we'll see how to perform matrix concatenation and basic arithmetic operations like addition, subtraction, multiplication and division on images. Then we'll see how to visualize these results using IMShow and subplot commands. So here in this video we will see how to create two 40 cross 40 matrices, one filled with ones and the other filled with zeros. Then we'll combine these matrices to form larger matrices such as C and D. We are using the notations C and D here. Then various operations such as addition, then element-wise multiplication, subtraction and scaling are performed on these matrices, which will result in new matrices which will be representing by capital A, M, S and D. And finally we'll visualize these matrices using the IMShow function and subplot layout, allowing for a clear comparison of the different transformations applied. So we'll see some of the basic arithmetic operations on the image matrices. First is the addition. So it will add pixel values of two matrices and it will brighten the regions where both inputs are white. And it can be used for image blending or combining masks. Then comes the element-wise multiplication, where it multiplies each corresponding element. This is common in masking, where one image masks the other by turning the pixels on and off. And here the logic used is 1 multiplied with 1 is 1 and 1 multiplied with 0 is 0, similar to a AND logic gate. Then we have subtraction, where it highlights the differences between the two patterns and it is used in edge detection and motion detection. Next comes the scalar division, that is the division by 4, which will scales down the pixel intensity and it is used in normalization and brightness adjustment. Then comes the scalar multiplication, where it will amplifies the pixel intensity and demonstrates contrast enhancement or brightness boost. These are the operations, syntax and the description. So when we are going for addition, it will be like C plus D. We are adding the matrices and it adds the corresponding elements of both the matrices. Then we have scalar multiplication, where it will multiply each element of the matrix by 10. You can vary this number. Then you have multiplication, that is C dot star D. So here it is element wise multiplication. The difference between these two is here it is a scalar multiplication, where you are multiplying each element by a number, by a scalar, okay, which is variable. Where here multiplication, you are multiplying the elements of both the corresponding elements of both the matrices. So it is element wise multiplication. Then comes the subtraction, that is C minus D, where we'll find out the difference between corresponding elements. And next comes the division, that is C by 4, where each element is divided by 4. Next is grayscale image visualization. Although we are using matrices of zeros and ones, that is binary, this Scilab or MATLAB, it will interpret any matrix as a grayscale image, where the 0 is represented as black and 1 is represented as white, and the values in between are nothing but the shades of gray, and the values which are greater than 1 are automatically scaled or clipped off. Okay, so next is we'll see what is ones and zeros. So ones in bracket n and zeros in bracket n. This n is variable. Here we are using ones 40. Okay, here we are creating we are creating a matrix of 40 cross 40, where every pixel will be represented as 1, and it is displayed as white in the binary images. And then we have zeros of 40, where it is a matrix of 40 cross 40, where every pixel is represented by 0 and it is displayed as black. And these are useful in mask creation, pattern generation, and the morphological operations. Next, we have some matrix concatenation, where we will take a matrix C is equal to square bracket A space B semicolon B space A. Okay, so if we write this command, then we'll get this type of matrix, that is 1 0 0 1. Okay, so this will give you a diagonal white block pattern like a checkerboard. So this will be one is what? One is black, one is white, no? One is white, black, black, white, like that. Okay, then comes D, B space B colon semicolon A space A. So B is nothing but 0 0 and A is 1 1. So it will create a image with black at the top and white at the bottom. So now we'll see the program here. A is equal to 1's 40. So here it will create a 40 cross 40 matrix with all the elements equal to 1, which will be white block. Then we have B is equal to zeros of 40, which will create a 40 cross 40 matrix with all the elements which are equal to 0, which is a black box. Then we have C is equal to A space B semicolon B space A, which will combine A and B into a 2 cross 2 block matrix, which will look like a checkerboard. Then we have D is equal to B space B semicolon A space A. So here it is a different block structure combining black and white blocks. Next comes A is equal to 10 into C plus D, where this it will add first the matrices C and D, then it is multiplied. Okay, then that is it is scaled by a value 10 here. Next we have M is equal to C dot star D, where this is nothing but the element-wise multiplication of the matrices C and D. This is the scalar multiplication. This is the element-wise multiplication. Next is capital S is equal to C minus D, which will subtract D from C. Okay, that is the elements of D from elements of C, corresponding elements. Next you have D is equal to C by 4, where it will divide each element in C by 4, which is a scalar division. You can change this. It can be 4, 5, 6. You can take any number. Next you have figure, which will create a new figure window. Okay, figure semicolon, new figure window. Then we have these all commands, that is subplot 3 comma 2 comma 1. This is for rows, this is for columns, and this is the first quadrant. Okay, so here it will create 3 rows, okay, and 2 columns, and this is the first quadrant. I am show C. So here the image will be shown in the first quadrant, C image. C image is what? This one. Whenever you perform this operation, that image will be displayed in the first quadrant. Then subplot 3 comma 2 comma 2. Third 3 rows, 2 columns, second quadrant. In second quadrant, which image will be shown? D image, this one. Next we have subplot 3 comma 2 comma 3. This will be in the third quadrant. A image will be shown. Next is subplot 3 comma 2 comma 4. In the fourth quadrant, M image will be shown. Okay, this one. Next 3 comma 2 comma 5, fifth quadrant, S image. I am show of S. Then we have subplot 3 comma 2 comma 6, that is in the sixth quadrant. I am show D, this image. Okay. Now these are the images which are being created. So this is your C. Okay, this is the C. Then this is D. This is capital A. This is capital M. Then you have capital S and capital C, capital D. That is here you are performing. That is combine C. Wait, I'll show you one by one. You can understand here. This one. Okay, this is nothing but C is equal to A, B, B, A. Okay, then this is B, B, A, A. Then you have A is equal to C plus D, with then scaled by 10. You will get this type of image. Then you have sorry, this is oh, sorry, this is yum. Okay, this is yum is equal to m is equal to c dot star d. This is not a is equal to, this is c dot. Okay, c image, capital C, capital M image. This is capital yum. Okay, element wise multiplication it is. Then we have capital S is equal to c minus d. We'll get this one. Next you have capital D is equal to C by 4. So here when you are multiplying, you are getting the shades of gray. Okay. So these are the images. Now these are the operations and the symbols. So matrix creation, for matrix creation we'll use ones and zeros. So here our purpose is to create synthetic image blocks. For concatenation we'll use such type of commands where it will arrange image patterns spatially. Then you have addition, multiplication, subtraction, scalar operations. Additions are used for combining the intensities. Multiplication is used for masking and logical AND. Subtraction is used for difference detection, and scalar operations are used for brightness control and normalization. Okay. So here this is the overall thing which we have seen. That is we are initializing the matrices by using ones matrix and zeros matrix, and we are performing these mathematical or arithmetic operations on the matrices, and we are using im show function and the subplots for matrix visualization. That is for the images which are being created, we are using these to display. So here matrix D, it is used for division and scaling. Okay. Then small matrix D, it is used to show zeros and ones, whereas small c matrix, it is used to display ones and zeros. Okay. Both are opposite. Then matrix S, it is for subtraction and finding the difference, and matrix A is for finding the sum and the scaling. And you have matrix M where you have element wise multiplication. So here this is nothing but the element wise multiplication. This should be actually M. Fine. So I'll show you it here. This one, M. M is equal to C dot star D. Okay. So there is a mistake here. These are the practical applications. It is used in image masking, which is the element wise multiplication. Then it is used for pattern recognition, which is used for template matching. Then we have contrast enhancement, which can be used in scaling, and logical operations in binary image analysis for image blending. Here it uses the matrix concatenation and the arithmetic operations. So even with simple matrices like ones and zeros, we can perform powerful operations to simulate basic image processing task. And these foundational concepts are essential before diving into advanced topics like filtering, transformation, or machine learning in computer vision. I hope you have understood this. Now we will see how to execute this in the MATLAB, sorry, Scilab. So first I'll copy this program. This is the Scilab. Double click on this icon. It is an open source software. You can easily download it in download and install. So here we'll go to the this icon, that is the file icon, or then here you can go to this icon, this one, okay, and open a new file. Now I'll paste the program here which I have copied. Fine. Now you have to save this. So we'll save it as, I will save it as mat op. Okay, that is matrix operations. You have to save it with the extension .sci. Like in MATLAB, you save it as .m. Here you have to save it as .sci. So we'll save it. Okay. Now you have to see this toolbar and you have to click on this icon, that is save and execute. Okay. So this is save and execute. So we are getting this one. Okay. This is the figure which will be displayed. Fine. So this is how you execute in the Scilab. And here you have one more window which is called as the console window here. Okay, you will see if you have any like errors in the programs, you will see here. In MATLAB, you will get in the same windows. Okay, that is on the same screen you will get, but here you have to see in this console. Okay, here you will be having two windows. One is of console and another is where you execute and write the, where you write and execute the program. Okay, so this is how you execute the program. So this is the figure which will be displayed. I hope you have enjoyed watching this video, and if you have any doubts, you can write it in the comment section, and do like and subscribe my channel. Thank you.